Hello guys and welcome to Yummy Math. This tutorial is on quadratic equations. So what is quadratic equation? Any equation which is in this form, ax square plus bx plus c equals to 0 is a quadratic equation where a, b and c are real numbers. We'll see what real numbers are. And a should not be equals to 0. If a is 0, then this term becomes 0 and we are left with bx plus c equals to 0, which is a linear equation, not quadratic equation. Okay, so let's see what is real number. Real number is nothing but any point on this number line, right? From minus infinity to infinity is a real number, but this can be represented in numerous forms. For example, a, b and c can be represented in any form, like minus 100 or minus 50 by 7. I'm just taking some random examples. Minus root 10 by 3, minus 2 or 3, or root 7 by 3, or 3 into root 14 by 7, right? It can have any value. Okay, now let's look at some examples of quadratic equation. So this is a quadratic equation, right? A very simple example of quadratic equation. Let me write few more examples. X square minus 4x plus 4 equals to 0. So what are the values of ABC here? A is 1 here, right? B is minus 4 and C is also 4. Let's take a few more examples. Minus 2x square plus 3x plus 5 equals to 0. 3x square plus 8x plus 20 equals to 0. X square minus 9 equals to 0. So this is also a quadratic equation. The value of a, b and c here are: a is 1, b is 0, right, and c is minus 9. This is one more example. Under root of 2 by 3, x square plus 59 by 27 x plus 48 equals to 0. X square plus 49 . Okay, so these are some examples of quadratic equation. I think it's pretty much clear to you guys how quadratic equation looks like. Now let's see some examples of equation which are not quadratic. So it's very simple. Any equation which is not in this form, ax square plus bx plus c equals to 0, is not a quadratic equation, right? Let's take some example of these also. So this is clearly not quadratic. X to the power 4, 3x square plus 9. Again, this is also not quadratic.
Okay,
Okay, here this is power 3, not power 2. So x to the power 3 minus 4x plus 5 equals to this is not a quadratic equation. X square plus 2 root x. This is also not quadratic. None of them are quadratic. X cube minus 9. And this is also not quadratic equation, right? Okay, let me take one more example, last example. X cube plus 3x square plus 2x plus 5. This is again not quadratic, right? Okay, so going forward, okay, the next topic is graph of quadratic equation. How does a graph of quadratic equation looks like? So what is graph? It is nothing but a curve that is made by joining all the values of y for different values of x. This will become clear after this example. Let's take few values of x. Let's say minus 20, minus 19, minus 18, then you have minus 1, 0, 1, 18, 19, 20. Okay, so for these value of x, we might get something like this for y. Once we put these values in this equation, we'll have a y something like this. This is again an example, so I'm just putting some values which will create a quadratic curve. Okay. If we draw these values on graph, this is y-axis, this is x-axis. Zero, 1, 18, 19, 20. Minus 1, minus 18, minus 19, minus 20. 2, 3, 4, minus 1, minus 2, minus 3, minus 4. Okay, so when x is minus 20, right, y is 4. So let's draw this. So it's here. When x is 19, y is 2. When x is minus 18, y is 0. When x is minus 1, y is minus 3. So let's draw this. Okay, if I put rest of the points, and if I join these points, we'll see a curve something like this. let me draw this neatly. This is x-axis, this is y-axis. So this is how graph of quadratic equation looks like. Now there are three use cases here, right? Let's look at these use cases. This is x, this is y. Okay, let's look at all the use cases in this graph itself. First is when a is greater than 0. Remember, when a is greater than 0, the graph looks like a cup, right? Like this. Now, when a is less than 0, the graph looks like hill, like this, right? Okay, let's talk about this thing. When a is greater than 0, there can be three use cases under this, right? Graph can either intersect x-axis, right, or it can touch x-axis, or something like this. Will never touch or never intersect, right? Similarly, when a is less than 0, the graph can intersect x-axis or it can touch x-axis. Third use case is neither touch nor intersect, right? So these are the possible use cases for a graph of quadratic equation. We'll talk more about it when we go through roots of the equation topic. Okay guys, let's play with the values of a, b, c and see how the curve changes, right? So here we can see a is equals to 1, b is equals to 0 and c is equals to 0, which means the equation is x square plus 1, right, which looks like this. Now let me make a 0, right? So this becomes a straight line. If we change the value of b, this is a straight line curve, right? Now if, let me make b 0 again. Okay, now what happens when I make a positive, right? So remember, when a is positive, the curve looks like a glass, and when a is negative, it looks like a hill below x-axis and above x-axis, right? Now let me change the value of b and c and see what happens. You guys can also go to this domain desmos.com and just play around with this curve. Now let's make a negative and see what happens. Right, so this gives a clear picture of how the curve of quadratic equation looks like. Okay, so let's look at some quadratic curve in real life, right? A football in air makes a quadratic curve, right? because it's a projectile path, and the path of projectile is parabola, and the equation of parabola is quadratic equation, right? You might learn about parabola in your next class, but it's something like this: y equals to mx square plus c. This is the equation of parabola, which is a quadratic equation, right? I'm not going deep into this. Okay, let's go back. Okay, so a football in air makes a quadratic curve. Like this. Right? Let's go to next slide. Again, the same thing, basketball in air makes a quadratic curve. Okay, roots or zeros of quadratic equation. What does it mean when someone says find out the roots or zeros of this quadratic equation? In simple language, it's nothing but for what value of x, y is equals to 0, right? Let's take this equation: y equals to ax square plus bx plus c, right? So for what value of x, y is equals to 0, right? Let me explain this through curve. Okay, so as we saw, the quadratic curve looks like this. This is x, this is y, right? Let's talk about those three use cases again. The first one is this, where it intersects y-axis at 2 points, right? Second use case is where it touches the x-axis, and third one is where it's above or below x-axis. So in this case, it touches the x-axis 2 points. So this quadratic equation has two real roots. One is this one and one is this one, right? In this case, this curve just touches the x-axis, which means it has real root, but both the roots are same, right? And in this case, it neither touches nor intersect, so it doesn't have roots, or we can say it doesn't have real roots, right? Let's take one example, right? X square minus x minus 2 equals to 0. So if we solve this, we'll talk about how do we solve quadratic equation in next video. So x equals to 2 and x equals to minus 1 are the roots of this equation, right? So the graph will look something like this. So this graph will intersect x-axis at -1 and +2 because these are the roots, right? So it looks something like this. Right. So this is all about roots and zeros. Okay. Guys, if you like this video, then go to our Facebook page, which is www.facebook.com/yummyyummymath, and write a review. And if you have any question or doubt, please go at the end of this page and post your comment in the comment block. Thank you. Bye bye.